Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have our 25th lecture and will discuss the following topics. In this tutorial we will first learn about the necessity and methods of fuel oil purification. Then we will explore the necessity and methods of lubricating oil purification. Next, we will learn how gravitational force is used for fuel oil purification. After that, we will understand the need for centrifugal purification. We will then study the clarification process. Finally, we will learn about the purification process. Let's discuss these through the following slides. Necessity and methods of fuel oil purification. Fuel oils need purification before use in marine diesel engines to ensure efficient engine performance, reliability, and longevity. Contaminants found in marine fuels. Marine fuels may contain water, sludge, and catalytic fines, which have several harmful effects on engine performance, reliability, and lifespan. Effects of contaminants on engine performance. Contaminants in marine fuels may cause corrosion, clogging of filters, excessive wear of components, combustion, and emission related problems. Effect of water. Water causes corrosion of fuel pumps, injectors, and pipes. It starts microbial growth at fuel water interface and forms sludge. It leads to poor combustion, resulting in black smoke and carbon deposits. It can also form emulsion, which is difficult to separate. Effects of sludge. Sludge consisting of asphaltene and sediments may clog the fuel filters and injectors. They cause abrasive wear on fuel pumps, injectors, cylinder liner, and piston rings. They are also responsible for incomplete combustion, resulting in deposits on piston crown and turbochargers, which increases maintenance frequency and unplanned downtime. Effects of catalytic fines. Catalytic fines consist of aluminum and silicon, which enter the fuel during the refining process and are highly abrasive. They cause severe wear on fuel injection equipment, piston rings, and cylinder liners. They can lead to scuffing and liner seizures and can be removed only by purification. Methods of fuel purification. Marine fuels are treated to remove impurities by all the following methods before the fuel enters the engine. Gravity settling. Heavier particles and water settle at the bottom by gravity due to the density difference. It forms the first stage of fuel oil purification. It is very slow process and not effective for fine particles or emulsified water. Centrifugal separation. It uses centrifugal force to separate components of different densities. It is fast and continuous process to remove water and solids from fuel. Filtration. Filtration is the final stage of fuel cleaning before injection in the engine cylinder. Filtration can remove particles as small as 10 to 25 microns in fine filters. Necessity and methods of lube oil purification. Lubricating oil plays a critical role in marine machinery by reducing friction, cooling components, and preventing wear. Over the time, it gets contaminated and purification becomes essential to maintain engine health and performance. Contaminants found in lubricating oils. Contaminants found in the engine lubricating oils include wear particles, water, carbon, and oxidation products. Effects of contaminants on engine performance. Contaminants in lubricating oils may cause filter clogging or abrasive and corrosive wear of engine components, resulting in serious damage such as engine seizure. Effects of wear particles. Wear particles can clog filters and oil passages, disrupt hydrodynamic oil film, and result in metal to metal contact, causing localized heating, micro seizures, and surface fatigue. They act as catalysts to promote further wear and causing damage to bearing surfaces, crankshaft journals, piston ring, and liner surfaces. Effects of water. Presence of water in lubricating oil reduces oil film strength and alters viscosity, leads to metal contact between engine parts, and increases friction, wear, and risk of seizure. It can combine with unburnt carbon to form acids and start corrosive wear. Water in large quantity emulsifies oil, which reduces lubricity and increases foaming and oxidation. Effects of oxidation products. Oxidation of lubricating oil results in formation of sludge and varnish, which are responsible for clogging of filters and reducing the heat transfer. Oxidation increases oil viscosity, which reduces film strength, load bearing capacity, oil flow, and heat transfer, which is responsible for increased friction and wear loading to possible engine seizure. Oxidation of oil also forms acids which start the corrosive cycle and shortens the life of oil, resulting in increased frequency of oil replacement. Methods of lubricating oil purification. Treatment of lubricating oil is carried out both by centrifugal separation and filtration, which improves engine performance and its reliability. It also increases the service life of lubricating oil and reduces the operational cost. Centrifugal separation. It uses centrifugal force to separate wear particles, sediments, and water from lubricating oil. It is operated continuously as a bypass to the system for maintaining the oil quality. Filtration. Filtration is the last stage of lubricating oil purification before admitting to the engine. Both magnetic and fine filters are used to trap ferrous and fine particles as small as 5 to 10 microns with fine filters. Using gravitational force for fuel purification. Principle of gravity separation. Fuel oil before use is allowed to stay in the settling tank where solid particles and water settle down by gravity due to density difference. How is the force of gravity separation increased? Force of gravity separation is further increased by heating the fuel oil to a temperature of about 75 degrees Celsius, due to which density difference between oil and water increases and it helps in their separation. Removal of contaminants. Separated water is frequently removed from the drain valve. Heavy contaminants settle at the bottom, which are removed during the survey of settling tank at 5 yearly interval. Desired shape of settling tank. Settling tank has a narrow and deep construction so that large gravity head is available for separation and ship's rolling and pitching movements does not mix the separated water with oil again. Capacity of settling and service tanks. Earlier ships with manned engine room were provided with two each settling and service tanks of capacity 25% in excess to the daily fuel oil consumption. Dirty oil was allowed to settle for 24 hours before further purification through the centrifuge and was stored in daily service tank. Settling and service tanks were changed over after 24 hours for settling and consumption. Modern ships for unmanned engine room operations are equipped with one each settling and service tank of capacity about 50% in excess of the daily fuel oil consumption. How is fuel oil level maintained in settling tank? Unpurified oil is transferred from storage tank to the settling tank by the transfer pump automatically through float switches. Transfer pump starts when settling tank still has about 60% fuel oil remaining, which is topped up to about 90%. Settling tank is also equipped with a low and high level alarm to warn the duty engineer. An overflow pipe is provided to prevent spillage of oil in case of malfunction of automation. On modern ships, purified oil from service tank overflows back to settling tank. Need for centrifugal purification. We have seen above that water can be separated from oil in a settling tank, where separation of two liquids take place due to their relative density difference and the effect of gravity. Force of gravity separation. Force of gravity separation FGS is given by the equation FGS is equal to pi by 6 d cube rho w minus rho o into g, where d is the diameter of particle, rho w is density of water, rho o density of oil, and g is acceleration due to gravity. The gravitational separation process is very slow and take several days for purification, equivalent to centrifugal purification. The only option is to increase the oil temperature, which increases the density difference between oil and water. Increase of oil temperature is restricted to 75 degrees Celsius to prevent turbulence, which can again affect the separation. Gravity separation method is an intermittent process. Centrifugal separation increases the force of separation considerably, which is described below. Force of centrifugal separation FCS. The force of centrifugal separation FCS is given by the equation FCS is equal to pi by 6 into d cube into rho w minus rho o into omega square r, where omega is the angular velocity and r is effective radius. Both the angular velocity and effective radius are controllable in a centrifugal separator. The value of omega square r can be 5000 to 8000 times larger than g, depending on speed of centrifuge, which is about 6000 rpm, and the diameter of bowl is about 600 millimeter. Centrifugal separation can provide a continuous cleaning operation. Clarification process. Clarification is the process of separation of liquid, which is oil, from solids, which are contaminants. In addition, it can also separate a small quantity of heavy liquid, which is water. The sketch shows the conversion from gravity settling process to a clarification process. A settling tank can remove both solids and water, but process is very slow, which can be speeded up by centrifuging. As shown in sketch, the dirty oil enters the settling tank from end A and oil supply is maintained. We observe that solids are settled at the bottom near the dirty oil entry in accordance with the force of separation FGS due to gravity, and overflowing oil is clear of sediments and is thus purified and discharged from clean oil outlet B. If the arrangement is turned by 90 and centrifugal bowl is rotated around its axis, this will function as a clarifier. The term clarification is used to describe the separation of solids from a liquid. The centrifuge is now fed with dirty oil from the inlet A at the bottom. When the bowl fills with oil, clean oil starts coming from the outlet B. Heavy solids are separated from oil and collected at the bowl periphery in accordance with the force of centrifugal separation FCS. Solids may be removed separately and process is called clarification. Oil which contains little or no water is treated in a clarifier bowl where the impurities and water collect at the bowl periphery. The shallow and wide shape of clarifier bowl is preferred for separation of solids from liquid as it helps in increasing the separating force due to large radius. This additionally provides more space for rotation of solids to increase the interval between discharges. Purification process. Purification is a process of separation of two liquids, usually oil and water. In addition, it can separate a small amount of solids. The sketch shows the conversion from gravity settling process to a purification process. The operation of a purifier requires a water seal to be formed first. Thus, sealing water is supplied from inlet A until it starts overflowing from the water outlet B. Now, a weir CD is provided to arrange two liquid outlets B and C. The weir is commonly known as dam ring or gravity disc. Dirty oil is now supplied from A, which displaces some water depending upon the relative density of oil and water. An interface is formed between water and oil, and clean oil is discharged from clean oil outlet C. If the process is continued, water present in oil will settle down, causing overflow of equal amount from the water outlet at B, and purified oil will be discharged from the clean oil outlet at C. In equilibrium, distance between interface and water outlet H1 is equal to distance between interface and clean oil outlet H2 multiplied by density of oil. The position of interface can be controlled by the size of the gravity disk, which in turn is dependent on the density of oil. If the arrangement is turned by 90 degree and rotated around its axis, this will function as a purifier. Firstly, water is supplied from inlet A until it leaves from the water outlet B after forming the water seal. The dam ring CD establishes the height of clean oil outlet. When dirty oil is supplied from A, it displaces the water to form the oil water interface and clean oil leaves from the outlet C. The centrifugal separation of two liquids such as oil and water results in formation of cylindrical interface between the two. The positioning of this interface within the centrifuge is very important for correct operation. The settling or positioning of interface is achieved by the use of dam ring or gravity disc at the outlet of the centrifuge. Various diameter rings are available for each machine when different densities of oil are used. As a general rule, the largest diameter ring which does not break the seal should be used. Separated solids are collected at the periphery of the purifier bowl, which are periodically removed or discharged. A tall, narrow shape is prepared for a purifier bowl. This completes our study of necessity and methods of fuel and lubricating oil purification, use of gravitational force for fuel oil purification, need of centrifugal purification, and working principle of clarification and purification processes. This book has been written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It explains the concepts with simple illustrations and provides answers to all the questions that have appeared in the examination conducted by the Indian Maritime University. This book will help students prepare for the exam and also assist them in working safely with shipboard, auxiliary systems, and deck machinery. I hope you enjoyed the lecture. Feel free to share your feedback in the comment box. If you find the tutorial helpful, you may share it with your friends. You can also subscribe to the channel to receive notifications about upcoming tutorials. I'll be back soon with another lecture. Thank you for watching till the end.